So today we are going to look at how to find the 5-number summary. And we are going to do that using StatCrunch. And we are also going to learn how to construct box plots. And whenever you have a box plot, how to make meaning of the box plot. Where to see the Q1, the IQR, and other information that comes along with the box plot. Also, whenever we have a box plot, how do we identify the outliers? We are going to look at some examples too in StatCrunch, and then we are going to also see how to also deal with outliers and how to identify them on the box plot. So usually what you are going to be tested on in this chapter is how to find the 5-number summary. And also some problems are going to draw the box plots for you, or some you'd have to draw them. Either way, when you have the box plot, how do you answer questions under them? So what is the 5-number summary? This is the 5-number summary. It is very important that you know the 5-number summary in the right order. So the order here matters. You are going to have problems where they are going to ask you to find a 5-number summary, and they are going to order them. So you should be able to understand that with a 5-number summary, the first number is the minimum, followed by the Q1, and then the median. The median is also the Q2. And then this is Q3, the third quartile, and then also the maximum. The order is very important, so you don't have to mix them. So if you're asked to find a 5-number summary, this is the order. So you can't do maximum Q1. You have to be able to get this order right. So if I were you, I'll put this order in my cheat sheet so that whenever I'm asked to do that, I could be able to look at that and then use StatCrunch to get that. So what does this number mean? We know that the minimum stands for the smallest value. And then the Q1 is the first quartile or the lower hinge. So it's about a 25% of the observations that are below it. And also the median is also like the 50th percentile, and then the third quartile, which is also called the upper hinge. Also, when it's also the same as 75% of the observations are at or below it. And then the maximum is the largest value. So it's very important that you get this order here right. And so this is an example here. I want you to find a 5-number summary. In this class, you are asked, you can use StatCrunch. So why don't you go in StatCrunch, put in these numbers, and then find a 5-number summary. So you go on StatCrunch, you enter the data set 2, 4, 7, 10, 12, 14, 18. If you're asked to do this on test, to save time, you don't necessarily have to label it. Is that okay? So remember how I put in the data in a column form. Is that okay? If a student goes to do 2, 4, 7 in a row form, it's going to be very difficult to use StatCrunch to do the work. Is that okay? So make sure you input your data in a column form. Now we want to find the 5-number summary. So we learned this last time. So we just need to go to Start, Summary Stats, and then we select columns. And then we select the column where we inputted our data. In my situation, it is VAR1. Whenever you select that, it appears here. What is the other for the 5-number summary? The first is the minimum. So I click on that. When you click on that, it shows here, followed by Q1. And then the median. And then Q3. And then the maximum. So you see, and then I hit compute. And so it does that for you. On the test, they'll just put these 5 numbers like that. So you have to be able to know that the first number is the minimum, followed by Q1, median, Q3, and then maximum. Any questions so far? Who is having challenges in finding the 5-number summary? These are problems when they appear in your test, you shouldn't get them wrong. Okay, let's proceed. So now we can use the StatCrunch to find the 5-number summary. Last time we talked about using IQR to measure the spread for skewed distributions. What is the IQR? The IQR is the Q3 minus Q1. Again, you don't need to know this formula because you could find the IQR in StatCrunch. But just so you know, it is the upper quartile minus the lower quartile, or the upper hinge minus the lower hinge. Why do we use the IQR in situations to measure the spread in situations where the distributions are skewed? The reason is because the IQR is resistant to outliers. Is that okay? So outliers doesn't impact the IQR as much as it can impact the standard deviation. Now we want to look at the box plot. This is how the box plot looks like. So this is how the box plot looks like. So there are things you need to know. First and foremost, whenever there are outliers, you are going to see those observations here. So for example, you see, this is the box plot. So you see there is an upper outlier here. Is that okay? If there is a lower outlier, it's going to also appear on the left. So the first thing you are required to know is how to identify outliers on your box plots. So like I said, whenever there is an outlier on the box plot, it appears here outside. So you see here, or it could also appear here if it's a lower outlier. The other thing they want you to also know is for you to be able to recognize the median on the box plot. So this is the median. The median is this. Is that okay? So this is the median. And then also this is the lower hinge or Q1. And then this is the upper hinge or Q3. Is that okay? And then this whole thing here is the IQR. Is that okay? I go over again. You'd be asked to identify outliers on your box plot. Whenever there are outliers, you'd see in some of your homework problems that you'd have box plots where there are outliers. So whenever there is an outlier, you'd see it's going to appear here or here on the lower side. Is that okay? There could be lower outliers. There could also be upper outliers. Apart from that, you also expected to find the median on the box plot. So the median is here, the middle, right here. This is the median. Is that okay? This is the Q1 or the lower hinge. This is the Q3 or the upper hinge. And then the length of this box here is the IQR. Is that okay? And then these are the fences. So these are the basic informations that you are supposed to know whenever you are given the box plot. The other thing you are going to be tested on box plots So you see, this is also the box plot. Same labeling. And then the middle here is the median. This is Q1, this is Q3. And then sometimes, how do we get outliers? So it usually uses a rule, and then this is the rule. So whenever an observation is lower than this, it goes to the lower outlier. Whenever an observation is greater than this fence, it's classified as an upper outlier. You are not required to know this formula for this course because StatCrunch computes the box plot for you. What you are required to know is to be able to identify one whenever you have a box plot. Is that okay? But just know that how it computes the outliers in StatCrunch is using this rule. So the fences act like a cutoff. So whenever an observation falls outside of the cutoff, it classifies that observation as an outlier. The other thing you are also required to know is whenever you have a box plot, you should be able to tell whether it is symmetric, left skewed, or right skewed. It's very, very important. Whenever you have a box plot, you are required to be able to tell whether it is symmetric, left skewed, or right skewed. How do we do that? I'm going to show you a simple trick to be able to see. So first and foremost, let's look at the symmetric box plot. So for the symmetric, you can see, the first thing to see, you can see that the median line is in the middle. Is that okay? To be able to see whether a box plot is symmetric, the first thing you can see is that the median line is in the middle. Is that okay? So that tells you that that data or that distribution is symmetric. The other thing too you can also see is that the length of this, they are fairly equal. Now, for right skewed, you can see that that side is bigger than that side. Is that okay? Or the tail on the right is longer than that of the left. Does that make sense? This is very important. So you can see that the median here is not in the middle. Is that okay? it looks like the upper side is longer than the what? The lowest dead side. Is that okay? That tells you that the distribution is right skewed. Or you could also look at the tail here. You see here is longer than this side here. Is that okay? We already talked about how to use histogram to detect that in previous chapters. So these are the histograms. And also for the left skewed, you can see that you see where the median is. So you see the bottom side is also, you see here is also longer or bigger than this part. Is that okay? And then you can also see that the tail on the left is longer than that of the what on the right. This is very important. Any question on that? Okay. So these are the various histograms which you know already. Sometimes too, your histograms are not going to be vertical. They can be horizontal. It is the same idea too. So for symmetric, you see it's in the middle. The median is in the middle. For right skewed, you see this side is longer than that of this. You can also see from the tail here, this side is also longer than that side. That should tell you it's right skewed. And then for left skewed, you see the tail is longer towards the left. Or this side too is longer than that of the right side. So regardless whether the box plot is horizontal or vertical, you are expected to be able to tell whether it is symmetric or right skewed or left skewed. So all that I said is what is here. And so if there are outliers, you'd be able to see them. So with a box plot, we can find the median, the lower hinge with the Q1, the upper hinge, and also the length of the box is the IQR. So for example, the length of this box here is the IQR. Is that okay? Good. One thing too I want you to have in mind is that if this box is longer, it means that the variation is a lot. Is that okay? If it is shorter, it means the variation has reduced significantly. So one thing you have to always have in mind. So whenever you have a quantitative or numerical data, and then we try to use the histogram or the box plots to graph them. We want to be able to tell the shape, outliers, the center, and also the spread. So this is also to remind us what we learned last time, that if a distribution is approximately symmetric, we use the mean for the center and then the standard deviation for the spread. I have spoken about this in previous meetings. I just want to emphasize that because it usually comes on your test and you are still going to have some students getting it wrong. For skewness, if a distribution is skewed, whether left skewed or right skewed, the best measure for the center is the median and then IQR for the spread. The reason is that the median and the IQR, they are robust. Whenever a distribution is skewed, it means that there are some unusual observations, or there are observations that are large. And so the median and the IQ they are resistant to those unusual observations. That is why we rely on them for the measure of the center and then the spread. So last time we talked about this. If a distribution is right skewed, it means the mean is greater than the median. If approximately symmetric, the mean and the median are usually the same. So what we are going to do now is to load this data set, obtain the 5-number summary. We are going to construct a box plot and then see if we can be able to make some analysis from that. But what I want you to do before we go in StatCrunch is to read the question here. The question is asking whether men and women marry for the first time at the same age. Is that okay? How do we answer that? We are going to do that in StatCrunch. So I want you to open StatCrunch and then load this data set. I have already taught you how to load data sets in StatCrunch. So please open your StatCrunch and then load this data set. So to do that, we go to data and then we go to load and then we go to shared data sets. And then we have this. Go to data, load, then share data set, and then type in the name of the data. So it is CH4EG. And so this is the data set. Okay, let me check. Yes. Who else is trying to load the data set so I can help? So we click on this, and then there we go. This is our data set. So what I want you to do is to find the 5-number summary for men and women. Try to do that by yourself. Find the 5-number summary. We're trying to find the 5 number summary. So in this example here, we want to do it for both men and women. Is that okay? Because those are the two things we are comparing. So to do that, so where do I go? Anybody to remind me to get a 5 number summary? Where do I go? Starts, good. And then we go to summary starts, and then we go to columns. Good. We are interested in the 5 number summary for men and women. There is no point in finding the number summary for year. It doesn't make sense. Is that okay? So I click on, because I'm using a Mac, I hit on command and then I add men to it. Is that okay? And then what are the 5 number summaries? What is the first one? Minimum. So I look through minimum and then I find it here. Followed by Q1, followed by median, Q3, and then maximum. And then I hit compute, and then I have this. Now, the purpose of this class is not only to get these numbers, but what can you make meaning of this summary here? Who would help us to interpret this? So the question is asking whether men and women marry at the same age. I think so. What is the question saying? Let's try to check. Yeah, it's asking whether men and women marry for the first time at the same age. So you have this first summary. What can you say? Who would help us? Just try. Mm-hmm.
Women have the lower minimum, Q1, median. They have lower everything.
So what does that imply?
They get married younger.
Yes. Is that okay? So they get married younger than men. Is that okay? So this is what the summary statistics is telling us. Because you can compare their median and see that, oh, the women have a lower median than the men. Is that okay? Also, when you look at even the minimum age is 2, and then the maximum age is 2. Is that okay? So this summary statistics is giving us an idea that women marry earlier than men based on this data set here. Is that okay? The other thing we can also do is to get box plots. Box plots are very important because it gives the pictures right away. It gives the idea quickly. Is that okay? So I'm going to teach you how to get box plots in StatCrunch. So to be able to do box plots, remember box plots is a graphical presentation of data. So every time we go to graph, is that okay? So you go to graph and then you see box plots. Do you see the box plot here? We'll click on that here. I do again. So I go to graph, I scroll through and I look for box plot. Box plot is right here. Is that okay? In this class, we are not going to learn how to use all these visual steps. We are going to just use some of them. So whenever we do, you just have to follow. So we do box plot here. Is that okay? We are interested in box plot for men and women. If it's only women, we just select women. Is that okay? If it's only men, we select men. But here we are looking for both of them. So I hit command and I select both men and women. So please do so on your end too. Have you all been able to do this? Okay. And then we hit compute. And then we have this. The first question I want to ask you is, do you see any outliers in any of these box plots? Yes or no? How many of you think there is an outlier? How many of you think there is no outlier? Okay, so we are all good on this. We are all good on identifying whether a box plot has an outlier or not. The other question I want to ask is, we learned that the box plot can also tell us the skewness. Now, is this box, let's look at both of them because they look similar, right? So what do you think? Do you think it's symmetric? Yes or no? So we know if it is symmetric, the median would have been in the middle, correct? And then the length of this and that would have been the same. So we agree it is not symmetric. Now the question is, so if it is not symmetric, it means that it is skewed. What type of skewness is this? Is it right skewed or left skewed? How many of you think it's left skewed? Just show by your hands. How many of you think it's right skewed? Okay, so we all agree this is right skewed. Okay, how do we see that? First and foremost, you can see that here is bigger, it's to the right. I want to select those data sets. And then you can also see the tail here. It's longer to the right than to the left, you see? So that is also an idea to be able to tell if it is right skewed. So we can see no outliers. We can also tell that both women and men, they are all right skewed. Okay. Now, what can you see from here? You can also see that the median age for women is lower than that of men. Look at where the men are. It's around 24. Women is around 21 point something. Is that okay? So it's still the same picture, just like we did using the summary statistics. So you can see that men marry later than women. Is that okay? Any questions so far? Now let's look at the IQR. What is the IQR? The IQR is the length of this box here and the length of this box here. I kind of think that the length are pretty the same. Is that okay? We are going to have situations whereby the length are not the same. If such a situation happens, the one that is shorter means it is more consistent, or the variability is less as compared to the other one. These are the things that you are required to know. Is that okay? Getting these things, the machine can do it for you, but it's your responsibility to be able to make meaning out of that. Is that okay? Good. So let's proceed. So we've been able to answer the question that women marry earlier than men. Is that okay? We use the summary stats, and we could also use the box plots too. So we answered this. We are going to do another example. But before we do that, it's very important that you understand the problem. That way, you'd be able to appreciate it more when we get to StatCrunch and begins to show those visual graphs and pictures. So spend time and then read the problem. When you finish with the problem, I want some of you to be able to explain what is happening to us before we go into StatCrunch. So who would summarize the problem for us? What is happening?
She's trying to find how good her like coffee cups were, so she had multiple coffee cups. She tests, she measures them 8 times, and she records the difference, like not the temperature, but like the difference between the last measure.
Okay,
I think for this,
okay,
yeah, which is the best cup.
okay. Do you all agree with that? Okay, so how do we so the one with the smallest difference, so how do we determine the best cup?
One that has this amount of differences,
Exactly.
like just like the smallest numbers.
Exactly. So the one with the what? The smallest difference, that means that it's able to retain the heat. Is that okay? Or stuff doesn't get cold quickly in that cup. Is that okay? So to get a data set, let's go to Start Crunch and load this data. Have we all been able to load the data? Anybody struggling to load the data set? Okay. So let's find the 5-number summary first. So I know most of you might do summary stats, columns, just do this. And then let's try to say maybe the mean. You see, when you do this, we don't know whether what is for which cup. Is that okay? So to be able to get that, we do stats, summary stats, column, we select where the data is. And then here, because we have various types of cups, and then those cups are called container. So we try to do group by the type of container. So it's going to separate them. Nissan, say, cups, it's going to do that. So the 5-number summary, what is the first one? Minimum, followed by Q1, and then median, and then max. And then we hit compute. There we go. Is that okay? So this makes meaning. Is that okay? So when you look at this, so based on this data here, what do you think? What do you think? What is the best cap so far? Looking at this 5-number summary. Do you all agree with that? Because it has the lowest temperature difference. Makes sense because the person says that I heat the water, put in the cup, and then I try to take the temperature after some time. Is that okay? So the best cup is the one that is able to retain or maintain the temperature. Is that okay? Because you don't want your coffee to get cold. Is that okay? So Nissan, what is the worst cup here? Do you all agree with that? So he's saying sick because you can see, look at the median, has the highest median, and even look at the maximum too. Okay, now I want you to do the box plot. Let's try to get the box plot. And then we should group by container. And then we hit compute. And then we have this. And so when we have this one here, first and foremost, you can see that, like he said, Nissan looks like the best cup. You can see it has the lowest median. Look at where its median is as compared to the others. Is that okay? And then 6 seems the worst because look at where its median is. This is the median. So you trace it somewhere here. It looks like at 15 or something. Is that okay? And then are there outliers in any of these box plots? No. And the skewness seems to be something that is the same. So what do you think is the skewness for SIG? So this is SIG. This is the box plot for that. Is it symmetric, right skewed, or left skewed? It is right skewed. Is that okay? Because you can see, look at here. I think it's the same for the other box plots too. Good. Now, you can see that the IQR for Nissan is shorter than the rest. Do you see that? Look at the IQR for SIG. Look at the IQR for Starbucks. And then that of Caps. But look at this one. So the shorter means that it is consistent. It means the variability is low. Is that okay? So it means that we can rely on this, whatever Nissan is saying, whatever this cap is saying, we can rely on that because the variability is low. Is that okay? Good. Any questions so far? So you can be able to construct box plots in StatCrunch and also make meaning of them. So you can be given a box plot, you can be asked to find the median. This is the median. Lower hinge or Q1. This is it. Upper hinge or Q3. And then also if there are outliers. Is that okay? Good. And whenever they give you two box plots and they want you to make comparison, you just have to look at the medians. For example, if this and this, we can see that the median for this is lower than that because it's plotting on numbers here. Is that okay? So this is lower than that of that one. So if you are to rank the caps, so we already established that Nissan looks like the best and then SIG looks like the worst. How about caps and Starbucks? They are pretty much the same, isn't it? Because look at where their median is. And then, so this is what you are required to do or to understand. So let's proceed. So with box plot, you can see the median, the spread, and if there are potential outliers. And the other thing we also want to talk about is time plots. So for example, if we have a temperature data or rainfall data, those usually come with time. So for example, the rainfall in January, February, March, so it's time. Is that okay? We can use time plot to display those information. Another example is with our marriage data that we had, we can also display those information using time, using the time plot, because it has years and then also the ages. So for time plot, it's used to display quantitative variable against time. So whenever we have time and then the data, we could be able to use time plot to be able to display that. And then time plot is very, very important because it gives you the overall trend. Is that okay? So for example, let's try to use time plot to display the marriage data. And then you are going to appreciate what I mean, that it gives you the overall trend as compared to the box plot that just gives you those quick summaries. So let's go to StatCrunch and load the marriage data set again. So let me close this. I have my marriage data set, but I'll try to load it again. So we go to data, and then we go to load shared data set, and then we put in CH4 EG, and then this one comes up. We click on this one, and then we have this. So please load your marriage data set again. Have you all been able to load your marriage data set? So let's try to get the time plot. So to do that, we go to graph. So to be able to get a time plot, we go to graph, and then we go to multi-plot. So graph, multi-plot, and then we click on that one. So graph, multi-plot, and then you have this. The X variable is always the time. And so here, the X variable is the year. Is that okay? So we select that. So X variable is the year. Is that okay? And then the Y variable, here we want to show both men and women. So let's do it one. It only allows us to select one before we add, and then we can do the other one. So the Y variable, we could select women first. And then I want to show points and lines. You could do points, or you could do lines, but I want to do points and lines. And then because it's men and women, I have to include men too. So you just click on add here. Okay. And then I come and click on men too. And then I click add. You see? So it shows women versus year and men versus year. and then you hit compute, and then you have this. So what can you see? So you see this one is giving us the overall trend. Let me try to exit full screen. So you can see this is giving us the overall trend. Now, even let's look at, so you see men is in red and then women is in blue. So again, women marry earlier than men according to this data set. But the interesting thing here is that now when you look at 1900, you see their ages for women were like 22, and then along the line, it kept decreasing till 1960 thereabout. Is that okay? And then from 1980 thereabout, you can see even women began to marry later as compared to the previous years. Can you see that? You see getting to 2000s here, and then look at the 1900s. So you can see even for women, from 1980 to the 2000s, women began to marry later as compared to those previous years. You can't find this information on the box plot. So you can see the trend here. Now, why is it so? It could be that now a lot of women are getting education. A lot of them are doing advanced degree, graduate degrees, and all those kind of stuffs. So which is also causing them to marry later as compared to the previous years. Is that okay? And you can see same for men too. So there could be a couple of reasons that is what is causing this to happen. But again, the time plot gives us the overall trend, and we can be able to understand the data better. Any questions? So let's proceed. This time plot just tries to give you the picture. The other thing we want to talk about is the ogive. So for this one, it's just a graph of the percentile versus the data values. So that is what the ogive is. It's just a graph of percentile versus the data values. So I provided a quick example of that. So for example, if this is my 5-number summary, so the minimum is the same as the 0 percentile, the maximum is the same as the 100 percentile, and then Q1 is the same as the 25th percentile, the median is the same as Q2, which is the same as the 50th percentile, Q3 is the same as the 75th percentile. And then we can plot that. You see, these are the data values and these are the percentiles. So this is what the ogive is. So in summary, you should be able to know how to get the 5-number summary in StatCrunch. And the order is very important. IQR, you can also find that in StatCrunch, but also know it is Q3 minus Q1. And then also how the StatCrunch works to identify outliers in the box plot is using these range here. So these are called the fences. And also know that whenever you have a box plot, you should be able to identify outliers, tell whether it is right skewed or left skewed, and to be able to make analysis on the box plot, especially if you have different data, you can do side-by-side comparison. And also know that whenever the distribution is skewed, we prefer the median for the center, the IQR for the spread. So I think that is all for this chapter.